Hello everyone and welcome to a new video on MATLAB arrays. So in today's video we will discuss two important concepts. The first is array operations. So we will discuss array operations in MATLAB, and also we will discuss um, vectorized mathematical functions. So let's see. So we will start first with array operations. Suppose I have two arrays. Let's say, for example, array X contain three elements. Let's make something simple, 1, 2, 4. Array Y also contains another three elements, 1, 5, 9. So you could start doing operations in these arrays by adding them together, subtracting them from each other, multiplying them to each other element-wise, and we will see each one of these now. So let's start with addition. So when we do this, when we say x plus y, so what's basically, let's actually define this as an array z. What we will get is an array z where we have element-wise addition. So the first element in X is added to the first element in Y to give me the first element in Z. Similarly, the second element in X is added to the second element in Y to give me the second element in Z, and so on and so forth. So this is what we called an element-wise array addition. I can do the same thing with subtraction. So I can do X minus Y. Let's say this is an array W. And when we do this, again, we get an element-wise subtraction. So it's 1 minus 1, that gives me 0. 2 minus 5, and that gives me -3, and so on. So these are what we call element-wise subtraction. Now, suppose we would like to do element-wise multiplication. So what we mean by this, let's actually highlight it here. So we have x 1, 2, 4, and we have y equals 1, 5, 9. So if you ask MATLAB to do element-wise multiplication, let's say to calculate array U, so you are hoping to get 1 times 1, and that's basically 1, 2 times 5, that gives you 10, and 4 times 9, that's 36. So that's what you are hoping from MATLAB. Unfortunately, let's actually try to do this by writing naively x times y. MATLAB will start complaining and telling you there is an error using the multiplication operator. There is a lengthy message here, which we can read, of course, and learn something out of it. But the conclusion is that to perform element-wise multiplication, one needs to use dot and then the multiplication sign. So let's first solve the problem using MATLAB recommendation and then explain why this is the case. So MATLAB is asking me to do a dot here. So x dot and then multiplication y. And let's test this. Yes, it gives us the result that we expected here, which is 1, 10, and 36. But why? What's the reason? The reason is MATLAB is built as a matrix calculator. So originally, it's even the word MATLAB is the shortcut for matrix laboratory. And when we, at a later part of the course, when we discuss matrices, we will learn that from a matrix point of view, it's not allowed to calculate the product x times y. If you already have a knowledge in matrices, I can briefly illustrate this to you. So what's happening here is that the matrix A has 1 row and 3 columns. Matrix Y, I mean, if it is considered as a matrix, it contains 1 row also and 3 columns. And from the theory of matrix multiplication, it's not allowed to multiply x times y in a matrix fashion. The default in MATLAB is to consider everything as a matrix, and as such, it's not allowed really to calculate the matrix product of x times y. I am trying to convince MATLAB that I'm not trying to do matrix calculations. Instead, I'm trying to do element-wise array multiplication, and the little dot that we put here is sufficient to do this, or to force MATLAB to do element-wise multiplication. Now, the same idea applies to element-wise division. So suppose, again, let's bring the x again here and the array y here. Suppose I want also to divide x divided by y. So my goal here is to do element-wise division. So that would should give me, let's say, another array, let's say array b, capital B. So it's 1 divided by 1, 2 divided by 5, and 4 divided by 9. Again, if we ask MATLAB to do x, so let's call it capital B equals x divided by y, it will start to complain. Again, for the reason that we just described for multiplication. And as such, we need a little dot here. And if you put the dot, you get what we just calculated. So the array B, which contains 1, 0.4, which is 2 over 5, and 0.444, which is 4 over 9. So it turns out that for element-wise multiplication and element-wise division, we must use the dot to convince MATLAB to do element-wise array operation. Now, this also holds for exponentiation. So let's actually clear the screen here. Again, let me bring array x and array y. Suppose you want, in an element-wise fashion, to raise every element in x to a power that's the corresponding element in y. So that's basically, based on the numbers we have here, is going to be 1 raised to power 1, and then 2 raised to power 5, and then 4 raised to power 9. And that's a new array. Let's call this new array maybe capital S. So let's actually do this calculation here. Capital S equals x raised to power y. Again, for the same reasons that we explained, MATLAB will complain, and the only reason to force it to do this in an element-wise fashion is to put the little dot here. When we do this, we get what we expect, 132, and this big number here, which is basically 4 raised to power 9. So in summary, I can subtract or add without the need to the dot, because in fact the reason I don't need the dot for the subtraction and addition is that in the theory of matrices, it is actually allowed to add and subtract such arrays. So it doesn't really, the theory of matrices doesn't prevent you from doing this. That's why I don't need a dot. And in fact, element-wise subtraction is compatible with matrix subtraction or matrix addition. So let's summarize these operations here. In summary, if I have two arrays x and y. If I want to do addition, simply it's x plus y. Subtraction, simply x minus y. But for multiplication, for division, for also exponentiation, I must have a little dot here, and little dot here. One last warning on these array operations. If I have arrays of different sizes, so let's bring array x one more time. Suppose I have another array, let me call it maybe B, that contains 4 elements, so -1, 0, 6, and 7. Because the length of the array x is 3 and the length of the array g is 4, I cannot actually do array operations on them. So let's actually even try x plus g. And automatically MATLAB will complain that arrays have incompatible size for this operation. So when you try to do any one of these operations, you should make sure that the length of the array x equals the length of the array y, that you are, trying to do the binary operation on them. So usually whenever you see this error message that arrays have incompatible sizes, that one of them has a different length than the other, and then your debugging skill here is to try to print out the length of each one to make sure why they don't have incompatible sizes. All right, so let's move to the next part in this video, which is vectorized math functions. The nice thing about all MATLAB functions, the mathematical functions, the built-in ones, is that they are automatically vectorized. What do we mean by this? So let me bring again the array x. Suppose I want to calculate another array. So this is x given to me here, 1, 2, 4. I want to calculate another array. Let me call it array small t. It's basically the square root of x. What do I mean by this? I mean that t in itself is an array, and it contains the square root of the first element in x, so it's square root of 1, and square root of the second element, and then square root of the third element. So this means if I can simply go here and calculate t equals sqrt, which is the square root function of x, and it gives me the correct answer, it means that the square root function is vectorized. Vectorized means what? It means that it accepts x either as a scalar or a single number, and it also accepts x as a whole array. And in fact, all mathematical functions in MATLAB are automatically vectorized. So let's actually do this. Yes, it gives me the correct t. It's an array of 3 elements, and each element of t is the square root of the corresponding element in y. The same thing I can, all other functions are vectorized. So sine, cosine, exponential, all these are vectorized. So for example, suppose I want to calculate another function, another array. Let's call it array q. Q is the sign of each element of x. So it's sine 1, sine 2, sine 4. And by the way, the default is that the sign here is in radians. So again, I can simply write this as q equals sine of x. Why I can simply do this? Because the sine function is also vectorized. So I can give it as an input a whole array rather than a single number. So where is the vector word coming from? It is coming from the fact I can call it an array or a vector, right? So let's do this, and you get the sign of each one of these numbers. So pretty much any mathematical function is automatically vectorized in MATLAB. But this actually brings us to one last important thing to note. Suppose, let's actually do this here. Let me clear the memory altogether. Suppose I have a large array, let's say array x. It starts from 0, move in steps of 0.1 all the way to 10. So this is a very large array, right? I can actually check its length. So the length here is 101 element. And suppose I want to generate, let's write a mathematical expression here to calculate another array. So let's say another array is array z, and maybe z is, the exponential of x times sine x. Now let's interpret this. So let's actually start writing here. Z equals exponential function in MATLAB is exp of x, and automatically it's vectorized, times sine of x. We have to think a little bit here to see if this is the correct way to write it. So in fact, this in itself, when I calculate exponential or e raised to power x, that's basically is a big array that contains e raised to power 0, e raised to power 0.1, e raised to power 0.2. So because, and there are 101 elements of this big array. Similarly, sine x is another big array. So let's try to calculate or, write this array. It's a big array here that contains a sine of 0, sine of 0.1, and so on and so forth. So it turns out that when I multiply them here, and I put here a multiplication operator or a binary operation, that means that I'm multiplying an array with an array. And obviously, I need to do this in an element-wise fashion. To do this in an element-wise fashion, obviously, I must have a little dot here because I have array multiplied by an array. So let's actually test first if this works. Of course, it doesn't work because MATLAB is telling me to put the dot here. So I can correct this by typing z equal exp of x dot times sine x. I can put a semicolon, of course, to suppress the writing. And if I want to see what's in the array, I can display the whole array here, or I can display it as element by element. So for example, Z of 1, Z of 2, Z of 3, and finally Z of 101, which is the last element in this array. So that's the last element in the array that we have here. So in summary, we discussed in this video how to do array operations. We have to make sure that in addition and subtraction, nothing really to worry about here. There's no dot, there's no need for a dot. But for multiplication, division, and exponentiation, we have to have the dot. We also need to make sure that arrays have the same length when we do these operations. And we also learned something about the mathematical functions in MATLAB. Pretty much all of them are vectorized, which means that you can apply them to arrays and they will automatically calculate an array for you. And because of this, you need to be careful when you multiply mathematical functions or divide them or exponentiate them, because again, you are really doing array operations. And for multiplication, division, and exponentiation, you will always need this little dot. Thank you so much, and we will meet in another video.